Chapter 6, Section 1 and 2, Graphs of Relations and Linear Relations, Apprentice level. So first off, let's talk about what it means to interpret a graph. So below we have a woman. She walks away from a tree. Her distance from the tree versus time forms a relation, because we say that those two quantities are related. And is shown below. So below we have a graph. The horizontal axis represents time in minutes. The vertical axis represents her distance from her starting point, and that's given in meters. Then we have a bunch of points on the graph labeled A through G. So we say distance depends on time, right? It wouldn't make sense to say that the time depends on her distance traveled. Okay, we'd say that her distance traveled depends on how much time has gone by. Therefore, we say distance is dependent. Which makes time independent. In segment AB, the woman can be described as rapidly moving away from the tree. Why? Well, first of all, we know she's moving away from the tree is because as time goes on, the distance is getting bigger, right? The reason why we can say she's moving rapidly is because that change in distance comes with a relatively small change in time, okay? So in other words, that section of the graph is quite steep. So just in words, the line segment is, let's say, steep. Right. So let's describe her motion in each line segment. So look at what's happening B to C. Well, between B and C, we have a change in time, but notice how her distance actually doesn't change at all. Okay, the graph does not move up or down. So that means as time goes on, she's not moving at all. So she's motionless. So we'll say it briefly, standing still. Okay. In other words, not moving. Okay. C to D. Okay. Well, the distance is getting bigger, so she's moving away from the tree once again, but it's over a longer period of time. Hence, the line is not as steep. So I would say she's moving away, but not rapidly. So let's just say, I don't know, moderately. Not too fast, not too slow. So moderately. D to E. Well, notice how the graph now is going down as time moves forward. Okay. So that means her distance from the tree is getting smaller, which means she's actually turned around. So she's moving towards tree. Okay. Roughly how fast is she going? Well, it's not as fast as it was in A to B. It's a little bit steeper than C to D, but I'll just say moderately. Okay, there's no specific numbers here. We're just giving a rough description of what's going on. All right. E to F. Okay, once again, as time goes on, the distance is increasing, so she's moving away. Okay. But the line is quite shallow. It's not very steep, okay, because the change in time is relatively large. So this means she's, let's say slowly. All right. And finally, F to G. Well, that's exactly like B to C. As time goes on, the distance doesn't change. So once again, get it right, there we go. Standing still. In other words, not moving, motionless. There we go. All right. So far in our description of the graph, we've talked about the woman moving slowly, moderately, and rapidly. Well, what that could actually mean in real life, say when she's moving rapidly, maybe she's sprinting. Maybe she's running as fast as she can. And when she moves moderately, maybe she's just jogging. And slowly, maybe she's walking. We don't know exactly, okay, but could be that. Right, so during which line segment is she moving the fastest? All right, so during which segment does she cover the greatest distance in the least amount of time? Okay, well, you can tell by looking at, well, where is it the steepest? And we already established that it occurs during segment AB. Okay, that's clearly the steepest lying segment of that graph. During which line segment is she moving the slowest? Okay, now you could say, well, wouldn't that be where she's actually not moving at all? Well, I guess it depends on your interpretation, but if she's not moving at all, well, then she's not moving slowly. She's not moving at all. So I would say segment EF. Okay. She is moving, albeit slowly. During which line segments is she moving away from the tree? Well, that just means as time moves forward, when is the distance increasing? So when is the graph going up? Clearly, this happens more than once. So I'll say segments, and this occurs during AB, CD, and EF. Okay. Different speeds. Okay, the steepness is different, but nonetheless she's moving away. During which line segments is she moving towards the tree? Well, that actually only happens for one segment. That happens between D and E, because the graph is going down. Right, so notice how I've talked about steepness. Well, in mathematics, we actually can define steepness as a quantity, and we can measure it. And you will do that later on in this chapter, but I'll introduce it to you right now. The steepness of the line determines what we call the rate of change. Okay, so how quickly or how slowly is the graph changing? This quantity is known as the slope. So when you determine the slope of a graph, that tells you how steep it is. Okay? So you'll see more on this later.